Okay, so we're looking at 7.5 day 2, solve problems involving right triangles. Right, this here's a quick review of some of the homework questions. I had to make an adjustment to this form. You'll notice the equal sign right about here, and I added centimeters in here, and I put approximately. I think on your sheet it might have said, instead of an equal sign, it said the letter B. That's just a little glitch in the system, so sorry about that, and we got rid of that as well. So there's a quick look at the answer and how we calculate that. Hopefully that'll help you. For a homework question, it's actually not homework question number 8. It's just actually a review question, so ignore that. It's a review question to get you ready for exams. Um, this is a blast from the past earlier on in the term or the beginning of the year, where we looked at finding the point of intersection. So from the graph, the point of intersection seems to be 4, 5. So I just graphed the lines by using the coordinates. I had 0, 15, so I plotted 0, 15. I have 6, 0, so I plotted 6, 0. Same thing went for the other one. We've got 0, 0 as one of its coordinates and 6, 8 as another coordinate. Literally drew the lines, and it kind of looks like right there that the point of intersection, it looks like 4, 5. So what I've said here to the right is it looks like it's 4 or 5. We can quickly test this by subbing this coordinate into each equation to see if it satisfies them. If it does not, we must solve it via substitution or elimination. So let me just, and remember, a point of intersection is the solution to a linear system. So equation 1, I'm going to find the equation of each line so that I can sub into each equation and see if indeed 4 or 5 satisfies both. So I've got my two coordinates that I'm going to use for equation 1. I use a slope. The first thing I did was use a slope formula, y2 minus y1 over x2 minus x1. Plugged in my numbers, and I got a slope of a negative 5 over 2. Now I encourage you to pause the video and try this on your own, get the same answer, and then we'll move on together. Once I got y equal negative 5 over 2x, I put plus b. But we know what the b is because one of the coordinates is 0, 15. And of course, if you're on a Cartesian coordinate system, 0, 15 is a y-intercept. So therefore, I can quickly just sub in 15 for b right there, and I don't have to worry about subbing in a coordinate to solve for b. It's just given to me in the question. So look out for that on a test question or an exam question while you're reviewing. Sometimes there's easier ways of approaching a problem, save yourself a little bit of time. So I've got equation number 1 taken care of right here. Now I'm looking for equation 2. I've set up my two coordinates. Again, I use a slope formula, y2 minus y1 over x2 minus x1, plug in my numbers, and I get a slope of 4/3. Therefore, I got y equal 5, y equal 4/3 x, and there's no b. I've noted here and I've highlighted here, there's no b. How do we know that? Because one of the coordinates that the line runs through is 0, 0. And if a line runs through the origin, then it's got no y-intercept, and we call that direct variation. So we've got our two equations, y equal 4/3 x and y equal negative 5 over 2x plus 15. Armed with those, let's test the coordinate 4, 5 by subbing it into each equation. So equation 1, equation 2, you notice I'm communicating. I've written a title here and a title there. It's very obvious what I'm doing. I've rewritten the equation 1 and equation 2, and then I'm subbing in the coordinate 4, 5. Remember, be careful that you may be tempted to write the 4 first because it appears first, but y is 5 and x is 4. So we sub in those coordinates, and we find out 5 equal 5, left side equal right side. I'm not going to lie, I saw that first and I thought, yes, this is pretty good. I'm going to get the right answer and I'll be done my work. But unfortunately, when I checked it in equation 2, I got 5 equals 16/3. Of course, 15 divided by 3 would have been 5. And so I thought, oh, maybe I made a mistake. Double checked my work quickly and realized, no, indeed, it actually is 16/3. So I'm a little bit off. It's not exactly 4, comma 5. It's the coordinates is a little bit off from that. So because the coordinate's off, I now have to do a little bit more work. Now, there was a bit of a hint in the question, but it could be a trick, right? You're looking at this question that says, round your final answers to one decimal place. So that was kind of a hint that it might not exactly work out to whole numbers. But we're just following our work in steps regardless. We had to come up with those equations. Why not sub in quickly and see if we had the answer very quickly? So use substitution or elimination to find the point of intersection. I used substitution, so I said sub 2 into 1. I wrote the second equation because I'm subbing into it. So I started off with that second equation, y equal negative 5 over 2x plus 15. sorry, I started with my first equation because I'm subbing number 2 into the first. And you'll see there in red in the second step, I subbed in 4/3 x for y, because we know from our equation that y equal 4/3 x. Okay, so I subbed in, I've gone too far. Sub that in, and I ended up getting 4/3 x plus 5 over 2x equal 15. Not done yet. In order to get rid of the fraction, I multiplied everything by 6 in this step. And so I've done some cross reducing. Hopefully that makes sense. And then slowly I solved for x, and I got x equal 90 over 23, or approximately 3.9. Then I solved using this coordinate, 90 over 23. I then sub that into, I'm not sure what happened to these brackets, but that doesn't look right. Then I sub that into the second equation, 4/3 times 90 over 23, and I got y equal 360 divided by 69. I divided both of those by 3, and I reduced my fraction to get 120 over 23, which is approximately 5.2. And so I've made a special note here saying use exact numbers for the check. So for example, the fractions here. We don't want to start using decimals yet. So for the first check, I got y equal, I wrote my equations down for each check 1, check 2, wrote the equations down, subbed in what I know, was able to use cross reducing, etc. And eventually I got down to 15 equal 15, left side equal right side. And that was pretty good. Then I used check 2, the second equation. Again, I plugged in 90 over 23 for x, and I subbed in 120 over 23 for y, and I got 120 over 23 equal 120 over 23. Excellent, left side equal right side. Therefore, my point of intersection is 3.9 and 5.2. Remember, that's the only place I needed to round to one decimal place, because that's what the question told me to do up here, to round my answers to one decimal place. Now, if you sub in fractions, you're subbing in exact numbers, you want to do your rounding at the end. And that's basically all we've done here. All right, so here's an actual homework question, number 9, that you'll be working on, or you won't have to necessarily work on if you can get it done here. The max height, or you can understand it here, sorry. The max height, it talks about a girl, Cheryl. She is standing 30 meters away from a tree, and she wants to hit the ball. She's not sure if she should hit the ball and go around the tree and take 2 shots, or should she hit the ball and go right over the tree. But she knows with her clubs that the maximum height she can hit from this distance is 20 meters in the air. So she really needs to figure out how high is this tree. If it's 20 meters, she can go for it. If it's less than 20 meters, she'll definitely go for it. And if it's more than 20 meters, then she knows she's going to hit the tree. So how can we calculate this? Very simply, all the information is given that I wrote in this diagram is given to you. So she has a 40-degree angle. Her distance from the base of the tree to her ball is 30 meters. And so we simply do tan 40 equal x over 30, and we solve to find out x is actually 25.2 meters. So she should take 2 shots and go around the tree, because she can only hit 20 meters from this position, and the tree's higher than that, which means she'll hit the tree. Okay, that was a simple question, but question number 10 is requires a little bit more work from you, and it still pertains to the same golf ball question information. All right, that's it for this lesson, and we'll see you in class.